Hey everyone, welcome back, and today let's solve LeetCode problem 1408 titled String Matching in an Array. So we're given an array of strings words, and we need to return all the strings in words that is a substring of another string. And we can return this answer in any order. And they define a substring to basically just be a contiguous sequence of characters within a string. And there is also something called subarrays and subsequences for different data structures, but we don't need to get into that for this problem. So, something important to note is that we want to return all the strings and words that is a substring of another word. If we didn't have this another key symbol here, well, then we'd simply return the words as is, because every single word is a substring of itself, and so it has to be a substring of another different word in the input string words for it actually to be something that we append to the resulting list, right? So in example 1, we have our input array words to be the strings mass, as, hero, and superhero, and in this case our output is as and hero. The reason why is because as and hero are substrings of two separate corresponding strings in this input array words. Right, as you can see, as is actually a substring of mass, and hero is actually a substring of superhero. Both of these words are actually substring of words, other words in the input string words, except for themselves, and so those are the only two words that have that value that we'd append to our resulting list and what we'd eventually return once we're done checking all of these different combinations, right? And another way we could output this is hero and as. It doesn't have to be sorted in any lexicographic order or anything like that. We just want to return in some form all the words that have this property of being a substring of some different words, or at least one different word. In example 2, we have our input string array words to be LeetCode at encode, and in this case our output is at encode because both of these strings are actually substrings of other corresponding words in the input string words. As you can see, et is a substring of LeetCode, and code is a substring also of LeetCode. Et is not just a substring of itself, code is not just a substring of itself, and those are the only two strings that have that property in this input array string words. And finally, in example 3, we have our input array string words to be blue, green, boo. And in this case, we don't have any strings with that property in our resulting list, because no strings of words is a substring of some other string or some other different string. Of course, every single word or string in this input is a substring of itself, but it isn't a substring of any of the other words, because as you can see, blue is not a substring of green or boo, green is not a substring of blue and boo, and neither boo is a substring of green and blue. Notice what we just did there. We went through every single possible pair to actually check, and that kind of leads us to having nested loops in our solution as well. I won't try to spoil too much here, but note that we went through every single possible pair of subarrays to check if they were substrings of each other, which does kind of involve having nested loops in the solution. But anyways, that's why we have a null output, or rather an empty list. And for the constraints of this problem, we see that the length of our input string words is not going to exceed 100 and is not going to have a length for every single string above 30, which, keep in mind, are significantly very small inputs, at least relatively, right? So that kind of tells us that, okay, we don't have to have the most efficient of solutions. An n-squared solution might even be fine for this problem, right? So we're also given that words at any index I is only going to contain lowercase English letters, and all of the strings of words are always going to be unique, which is very, very important. It really just tells us that we won't have any weird invalid inputs or edge cases to deal with. We're always going to have distinct strings, and we're always going to have valid inputs with only lowercase English letters. We won't have any hashtags, we won't have any numbers, we won't have any other languages, it's just lowercase English letters. So with that problem statement, examples, and constraints out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so like we usually do on this channel, what is a good observation that we can really make to help us lead to our solution? Well, that observation really is that if a string is actually a substring of another string in this input array words, well then we can simply just detect it by checking if the larger string does contain the smaller one. And what is a good way to check that? Well, a good way to check that is basically using the Python built-in operator. It's literally called in. As you can see, it's highlighted in blue. It is actually a keyword in Python, right? We're literally just checking, well, if one string is a substring of another string. If one smaller string is in this larger string, which is very, very efficient for this problem and very, very simple to do as well. And also, to avoid any redundant checks, we're simply going to loop through every single string and compare it with all the other strings in the array, like we were talking about here in example 2 with those nested loops. And also, if it's a substring of any other string, well, then we can simply add it to our resulting list, because that's eventually what we're going to return, all the words that have this following property of being substrings of at least one other word besides itself in the input string words. Right, so for a kind of quick high level rundown of how our solution is actually going to be structured, basically we're simply going to first initialize a simple result list, right? It's simply going to store these strings that satisfy this substring condition, which is effectively what we're going to be returning at the end. And also, for every string in the input array, we're also going to iterate through all the other strings to check if it's a substring, right? Kind of the nested loops idea for all the different pairs that we're going to be checking and comparing. And if it is, well then sure, we can append it to the result. And finally, we're simply going to return the resulting list, because again, if a substring is in at least any other substring with any other pair in the nested loops, we know it fits this condition, because all it has to be is a substring of at least one other substring. And if that condition holds true, well then great, we can automatically append it to our resulting list. It doesn't have to be a substring of all the strings in this input string words. Okay, and eventually, again, we're simply going to return our result, which is going to be in the form of a list, right? So basically what I'm going to first do is actually initialize that list before I actually return it. And it's simply going to be an empty list, of course, because we haven't actually iterated over our input string words just yet. And again, what the purpose of this resulting list is simply going to, again, store all the resulting of the problems. It's simply going to store these strings that are substrings of other strings besides themselves in the input string words, right? Rather, input array words, I should say. So now let's actually have that nested loop kind of check to check for all the different possible pairs of substrings to see if they're substrings of another and to see if we have to actually add it to the result. So let's have our outer loop here. So for I in the range of the length of our input array words, and then for the nested loop here for j in the range of the length of our input string words. Oops, looks like it isn't indenting correctly. Okay, let's see why that is. Okay. No, this shouldn't be right. Okay, awesome. Anyways, so for j in the range of the length of our input string words, this is simply just standard nested loops here, right? Basically, I is going to be our outside iterator and j is going to be our interior iterator, right? So basically, again, to reiterate, this is simply going to iterate over all the different indices of the words array. I is going to represent the index of the current string that we're checking. In this inner loop here, basically, we're creating another for loop here where the variable j is going to represent the index of the string that we're comparing the current string words at index I against, right? So now we have to actually check, well, if the current index I, as long as it's not equal to j, so as long as they're separate substrings, they're not the same substring at the same index in our input string array, in our input array string words, and it should be an A, words at index I, if it's actually in words at index j, well then we know that words at index I is actually going to be a valid substring that is in another substring besides itself, where the indices of those two characters or words are actually different. And so if that's the case, we know that we can then result.append add to our resulting list the current word words at index I, because we know it's in words at index j. It's a substring of words at index j, which is a different index and a different string than I, because I is clearly not equal to j if that's true. And so if both those conditions hold true, we can then result.append the current words at index I and effectively just return the result at the end. But we are actually missing something very important here, right? Because we first, once we've actually appended that words at index I to our result, we want to immediately break on from this iteration. Why is that? Well, because once we've actually determined that words at index I is a substring of another string, we don't need to check it amongst the remaining strings, because we already know that yes, it's already a substring of some other index j string in our input string words. We want to avoid redundant checks and keep checking it, and so the moment we find that it's actually a substring of another word, we want to immediately break on and continue on to the next iteration, because we don't want to have any redundant checks. We don't want to keep checking for an index I that already is actually valid, it does actually have that property. So once we actually find the word at index I that has that property, we want to immediately break on from this iteration and move on to the next iteration, because we know it's already a valid string. And effectively, we simply have to return the resulting string, because it's going to contain all the strings that are substrings of other strings, right? So let's say I made syntax errors here. This should be accepted and it should be a valid solution. And as you can see, this is really just about as efficient as you can get. So basically, for a quick kind of like high-level rundown of how this code actually works, basically, we're simply just iterating through every single string in the words array after initializing this resulting list from this outer loop and then this inner loop here, right? And for every single string, we're checking, is it a substring of any other string in the array with these nested loops here? And as long as the current strings that we're comparing, as long as their indices are different, so that means they're actually different substrings in these string words, and also words at I is equal to words at j. So basically, if they're actually in or a substring of the other array string, well then we can add that resulting word to that resulting list. And effectively, once we actually find a word that has that substring, we want to immediately break on because we want to avoid redundant checks of checking a word that we've already confirmed to be true. And effectively, after all the comparisons, this result list is going to be returned because it actually contains all the matching strings, right? So for the time complexity of the solution, this is actually going to be a big O of n squared solution, where n is the number of strings in our input string words. The reason why is because, well, this is literally just a big O of n squared solution because we literally have nested loops, one outer loop and one inner loop for all the different string matchings and possibility pairs. And so this is going to be a big O of n squared solution for these nested loops to compare every single string with every other string, with every single pair that is. And the memory complexity or the space complexity is going to be big O of n. The reason why is because we're literally getting this extra result auxiliary memory extra data structure here. It's going to be about usually around or somewhat equal to the length of our input string words, because worst case, we might actually have all of the strings in this words in this resulting list. And so on average, it's going to be around big O of n, right? Because of course, we're storing the substrings in that result list. All the length of all the matching strings is actually added to that resulting list. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.